I know Pro Tools gives you a bunch of choices when you set up a session. They give you 44.1 thousand samples per second. They give you 48,000 samples per second. They give you, I have to write this down or I will forget. So you get 44.1 kilohertz sample rate. You get 48,000 kilohertz sample rate. You get 88.2 kilohertz sample rate. You get 96,000 sample rate. You get 176.4 kilohertz sample rate and 192 kilohertz sample rate. Now that seems like, wow, they give you a really wide variety of choices. Why do they give you such wide variety of choices? And some of these numbers of sample rates are kind of odd. Why would they choose 176.4? Why not just 50,000, 100,000, 200,000, whatever? The reason they do this is because 44.1 is the sample rate of the standard CD wave file. It's considered full quality audio. And they picked 44.1 because half of that is 22.05 kilohertz. And our hearing range is only up to 20,000. So they wanted to give it a little bit of leeway and keep it so that it's the highest frequency that a human can hear. So that's for audio only. This is actually, it's called the Red Book standard, is 16-bit and 44.1 sample rate. Red Book standard is what the standard CD was. I'm sure everyone's forgotten about CDs because everyone's into, MP3s and streaming, but that's what a CD was, or still is. 48,000 hertz is the standard for film and TV. Of course, film and TV has to have a higher standard than audio. They always try to allure people in with the great audio quality that they have. In fact, in the early days of recording, the film industry was instrumental in pushing along the recording industry. Bit depth is in film and TV is 24-bit, so it's a higher definition basically. And we'll talk about bit depth, and I'll relate it to this chart. So the next thing is, wow, this is familiar. 88.2 is twice 44.1. So this is high definition for audio only. 48K is half of 96. Interesting how these numbers relate. So this is high definition for film and TV sample rate. Doesn't mean you can only use it for that. I'm just saying that that's what it is, or why it was thought of to give you those numbers. Then, if you'll notice, take 44.1 and multiply it by 4, and you get 176.4 kilohertz. Right there, you're talking about 4 times the sample rate of 44.1. So this is ultra high definition for audio only. And then for film and TV, 48K times 4 is 192,000 samples per second. And that's ultra high definition for film and TV. Okay, so it gives you the high definition and ultra high definition for audio and for film. And that's why they give you these strange iterations of numbers, 176.4 and 88.2. And the reason they do that is for a very specific reason. So if at the end of the day, you're going to make a wave file of your mix, and it's going to be 44.1 kilohertz sample rate, because that's the standard audio CD format. If you start at 96,000 samples, it's a pretty complex conversion. The computer will have to convert 96,000 samples to 44.1 thousand samples per second. So it's got to eliminate certain samples to get to this, but it's not exactly easy because there's more than twice the 44.1. So, but on the other hand, when you have 88.2 thousand samples, the computer will just drop every other sample and you'll get back to 44.1. So it's a much easier conversion. And in essence, when you convert from 96,000 to 44.1 thousand, the algorithm is so complex that it induces more errors than if you just started with 88.2 thousand samples per second. So you actually get a better quality product in the end of the day when you convert it back to 44.1 if you start with 88.2 or you start with 176.4 kilohertz sample rate. And the same thing applies for film and TV. You want to eventually get to 48. So if I'm doing a jazz record and I want high definition on my audio, and I've had people, very, very famous engineers, come to me and give me mixes to work on, and they started at 96. I'm like, why did you start at 96? Well, it's better than 44.1. I'm like, yeah, okay. It's actually even better than 88.2 because it's a higher definition. I'm like, okay, but what's the final product going to be? The final product is going to be 44.1. So this would have been a better choice, even though it's a few thousand samples higher at 96,000 samples per second. So you have higher definition, but you end up with a lesser product. Interesting. So let's talk about bit depth next. That's sample rates. So now when you're setting up a project, you'll know, well, if it's just going to be for audio, I'll maybe work at 44.1, or I'll work at 88.2, or I'll work at 176.4. Incidentally, 176.4 is 4 times the data as 44.1 in terms of hard drive space per second of recording. Okay, so let's talk about the bit depth. So bit depth determines the dynamic range of the audio being recorded. Dynamic range meaning the quietest to the loudest part of the recording. Each bit equals 6 decibels of dynamic range. So it's 16-bit, which is the standard for a CD, like a physical optical CD, is 16-bit and 44.1 kilohertz sample rate. The bit depth at 16 is 96 decibels of dynamic range. And how they calculate it is 16-bit means actually 2 to the 16th possible values. So it's not just like 16 different divisions as your bits, it's 2 to the 16th. So there's 65,536 different divisions that when it samples a voltage it can put it to. Quite a bit. It's actually more than 44.1 thousand samples per second, right, in terms of the bit depth. 24-bit, if you look at it, it's 144 decibels dynamic range, or 2 to the 24th, which is over 16 million possible values on the vertical axis. So what it means is you've got a much smaller division, and so every sample can be more accurately assigned to a number. And actually, I used to work with a sampler that was 8-bit, and it was for drum sounds. And it was great. It was really thick sounding and not very definition oriented, but it was great for drums, and everyone loved it because it was 8-bit. So there are places for low definition, but in general you want to probably get the highest definition you can. But yes, that's why there's a sound difference. And I can hear the difference between 16-bit and 24-bit. I cannot hear the difference between 44.1 thousand samples per second and 48,000. But the 16-bit versus 24-bit is dramatic in terms of the definition in the bottom end and the definition on reverbs, and I'll tell you why. So if we've got more divisions on the vertical axis, that means if we hit a reverb and it's decaying, right, and it's like psh, and it's decaying, when it gets down to the quietest parts of its decay, when it gets down to the last bit, there's no other bit. It just goes like this. It goes, decays, and then it falls off. Then it's gone. So what happens if we've got more divisions is the tail of the reverbs can go longer before it chops off. And we recognize this quite a bit when we worked from analog to digital. We were quite aware that the reverbs seemed shorter and seemed less reverb in our mixes that were digital versus analog because of this principle that the tails would get chopped off, the reverbs kind of went away quicker, and we could hear it. So we'd put a little extra length on the reverbs to sort of compensate for that. But in the analog domain, when the reverb gets quieter and quieter and quieter, eventually it seeps into the noise floor of the tape. And then it sort of seamlessly just goes into nothingness. So it seems a little smoother. Pro Tools does 16 and 24-bit, and internal processing can be 32-bit. And 32-bit is definitely more precise because, as we mentioned, the more samples per second and the more bit depth per second, the closer you get to true analog again. So isn't this interesting? We started with analog, And now we're trying to get back to analog by having faster sample rates and higher bit depths. Our hearing can go, 1/4 of a difference, or a quadrillionth of a difference from soft to loud. So our dynamic range of our hearing far surpasses anything that you have in the computer. So the more accurate, the more dynamic range you have in the computer means the quieter the noise floor is to the signal, the less noise there is, the more accurate the recording is. Signal to noise is quieter, everything's better. So naturally you want to get to 32-bit, and the next step would be 64-bit. But as you do that, even in the bit depth world or the sample rate world, you dramatically increase how much data you create, right? Because every bit depth is another number. And every sample being faster and faster and faster creates more data. So your processor has to handle it. And if you're working on your internal computer processor, it's one thing. I've got an HD system, which means that I have a computer where cards come from Avid, and I put them in the computer, and they do all the processing, and the computer is just the host. The computer hosts all the graphics and all the commands. So the computer processor doesn't have to be powerful and doesn't have to be very fast. The cards internally do all the work, and each card is probably more powerful than quad-core or 8-core processors. So that's why you have to have special processing cards to handle high definition. And video processing also is the same way. Much, much, much more data. When you're working on a native system on your computer, it's using the computer processor to do all of the work, and it's doing all the graphics, and it's doing all of your internet searches, and it's doing your word processing, and it's doing your phone, everything, your Skyping, and it's doing all of that work all at once is a lot to ask of the little processor. And I would say the average album that I do, and I keep everything I record, and I start at 44.1 kilohertz sample rate and 24-bit depth, right? At that sample rate and bit depth, my average album is it's definitely under 100 gigs. So on a terabyte, I can fit 10 full albums worth of data on 1 terabyte. And you can go out and buy a 4 terabyte for, $125, $130. So it's kind of like, wow, this is way better for me in terms of how much material you can put on your storage device rather than a piece of tape that holds 15 minutes of 24 tracks. Right? It's dramatically different.